Okay, so here we're at the end of building both Chase Scheme and Idris. What I want to do today is spend a little bit of time exploring Idris, not too much. And the reason I want to do that specifically is because of this quantitative type theory. We'll open that. I can't remember which is the paper I'm after. Atke, maybe? Yeah. Where is it? Don't care about your category formulation. We'll probably just find it in the abstract. Yeah, so Idris is a dependently typed functional programming language. I've never actually used it. I've used Agda a little bit. I quite enjoy Agda. I think syntactically I prefer it over Idris. But Agda is evolving in a direction I'm not so interested in. Those people, I mean, it's a research language, right? So it's evolving in the direction that the research is, which seems to be towards higher order type theory, which until it starts producing results I care about, which it's not, I don't really care about it. There is something that Idris has, however, that I do care about. It's all dependently steps off, and that's linear logic, which is the ability to track resource usage. The simplest system of this is whether a resource is zero use, single use, or infinite use, basically. And the way that you would use this is if something is zero use, it's kind of interpreted as being available to the type system to do to use independent types and for type checking and whatnot, but it's not available at runtime. So one thing that you could do is pretty much erase that information from the runtime during a compile, because it's not able to be used at runtime at all. It's only able to be used in types. So that's cool. Infinite uses is what you kind of expect from most programming languages and variables in most programming languages. You can reuse a variable as many times as you want. There's no restriction on it. But the interesting thing about linear logic really comes in with single-use variables, which generally the way this works is if you open up a resource, for instance a file, you open a file, you get the type of that file is a single-use file specifically. So then if you want to read something from the file, what happens is you give the read function the single-use file, and what you get back is two things. You get one, you get the result of reading the file, say a string of bytes or something, and two, you get another single-use file, so that you can, I don't know, say read from it in the future or something. Now, what's the point of this? Why does that matter? What the point is when you close the file, you give it the single-use file, but it does not give you back a single-use file. So that file has been used, it's been consumed, and that file now cannot be used again. So this is one of the things that the borrow checker does in Rust. The borrow checker does a couple of things, but this is one of them. It tracks resource usage, and something that goes into, I think drop is the magic trait. Right, not really. This is the destructor trait. Okay. Well, okay. There's a couple of ways. Maybe calling drop is equivalent to using the resource. I don't know if that's true. I'm not super familiar with these kind of very specifics of Rust and all the edge cases. But anyway, the point is that in Rust, once the variable is deemed to be no longer in use, either because it just goes out of scope, either because it goes out of scope or its lifetime is has ended, then you can't use that variable again, and the resource is consumed automatically by the system, by Rust, I guess. So yeah, this is one of the things the burrow checker does, and I think this is a genuine improvement over C resource usage, which is kind of like, good luck, just remember to do it correctly. So I would like to have more familiarity with systems that have linear logic in them. But I also think dependently type programming has potential, let's say. I mentioned that I've used Agda a little bit. It's a massive pain in the ass to use. Some of that is because of the type system being so pedantic. Like, it's a proof checker, sort of. So some of that pain is because of the dependent types themselves, but really a lot of that pain is just the Agda tooling is just not very good, or wasn't very good when I used it. If you fuck something up, you will get inscrutable error messages. And sometimes the line that it gives you is correct, and you can kind of reason your way through why it's wrong. Sometimes the line it gives you is not exactly where the problem is, or what needs to be changed, I suppose. But I think it has good potential. So I really want to see these two things combined. One of the kind of appealing ideas with dependently typed programming languages is the kind of bug-free program. I mean, other than introducing Agda calls them postulates. I'm not sure what the equivalent in Idris is, but essentially unsafe. Other than explicitly saying, this is something I'm importing from outside the system, so its properties, just trust me, bro. In fact, that's maybe what it's called in Idris. It's maybe called trust me. I'm not sure. I've not used Idris, so this is going to be a little experiment today. But other than bringing things in from outside the system, everything inside the system is provably correct. That's a really appealing idea to me. But one thing that kind of is a bit of a downer about these languages is they're generally slow. Some of that slowness is in just the compiler, because it's got to run code and check proofs, which is quite an expensive operation. But it's also, they just generally produce pretty slow code. And some of that is because it's difficult to lower some of these structures into machine representations, but some of that is that you just don't really get that much control over memory usage. So they're usually garbage collected, for instance. And I'm not anti-garbage collection, but it would be cool if we could make a dependently typed language that was you could use as a systems language fairly comfortably. Or, yeah, I mean, you get the idea of what I'm saying. But what I'm saying is that, like, I want to extend the domain that these languages can be used in, or I would like to see that happen. And a big part of that, if you're going to fuck around with memory usage and system resources, a big part of that is being able to, as much as possible, prove that you've not overused a resource or used a resource when you shouldn't. Right, I would like to be able to allocate and deallocate memory and not have to worry about breaking the entire system every time I deallocate memory. And that's where linear logic comes in. It can really track that sort of stuff. If you dealloc memory, then you've consumed this single use of that block of memory, and you're not going to be allowed to use it again. I don't think Idris has this sort of capability. I'm pretty sure it's just a garbage collected language. But I want to practice mixing these two things. All right, that was quite lengthy. Ooh, I should have been watching this in case it failed. I had to fix a race condition earlier tonight. Looks like we're going well. This is also quite dangerous because if we doubled our memory usage, it'll crash. OpenBSD will kill it. Well, OpenBSD won't kill it, but OpenBSD will refuse to give it any more memory. So it'd be nice to somehow keep an eye on this, but I'm just gonna hope. I think. Maybe. We'll see. I might. This is, oh, whoops. Yeah, this is the first real stress test I've done for this program. Yeah. Anyway, the point of all that nonsense, I want to practice using linear logic and dependent types together. I would love to see it get practical enough to have languages that could be used as systems programming languages. And it would really be amazing if it could be a little more Agda and a little less Idris. Anyway, so I know that Edwin, is that his name? Yeah, Edwin has an example in here that he likes using. It's something to do, it's some kind of ATM. Yeah, dependent data types. Yeah, Idris 2. Yeah. Okay. Yeah. Oh, the run length encoding. Yeah, I remember that. That's his, that's an example he likes using as linearity. If f is evaluated exactly once, x is evaluated exactly once in the process. Nothing in the preload exposes an interface which requires it. Okay. Okay, that's fine. This looks like it's very slowly climbing. It's hard to tell because there's a lot of probably allocating and freeing frames and packets and internal buffering going on in formats, but yeah, it's hard to tell. It looks like it's slowly climbing, which means a memory leak probably. Almost certainly. IO and Idris 2, here we go. World is consumed exactly once, yeah.